Graphing linear equations, Lesson 3.4, Part B. The standards are 8EE6, 8F3, and 8F4. The objective is to graph linear equations using the slope and y-intercept. The essential question: why are graphs helpful? Slope-intercept form of an equation is represented by y equals mx plus b, where m is the slope and b is the y-intercept. Steps to graphing. Number 1. Label the y-intercept, which is represented with b. 2. Label the slope, which is represented by m. Number 3. Graph the y-intercept first. Number 4. Start at the y-intercept and use the slope to count to the next point. Number 5. Connect the dots in a straight line. Example number 1. Graph the equation y equals negative 5x plus 3. So first, we're going to identify our y-intercept, which is represented with b. So b equals 3. Now, we're going to identify our slope, which is represented with m. M equals negative 5. However, we always want our slope to be a fraction, so I'm going to write it over 1. So negative 5 means I'm going to go down 5, and then the 1 tells me I'm going to go to the right 1. So I'm going to go ahead and graph the y-intercept, which is at 3, and it crosses the y-axis. And then my slope, from there I'm going to go down 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. So that's where my other point is going to go. Now, I'm going to connect the dots. And then I want to include my arrows to show that this line continues. So this is the graph for the equation y equals negative 5x plus 3. Example number 2. Graph the equation y equals 1 over 4x minus 6. So first, we're going to go ahead and identify the y-intercept, which is represented with b. So b equals negative 6. Now we're going to identify our slope, which is represented with m. And our slope is 1 over 4. Since it's positive, that means I'm going to go up 1 and to the right 4. So we're going to start by graphing the y-intercept, which is at negative 6. So 1, 2, 3, 4, 5, 6. And then I'm going to go up 1 because my slope is 1 over 4. And then to the right 4. 1, 2, 3, 4. So my point will go there. Now I'm going to go ahead and connect the dots. And then I'm going to make my arrows to show that this line continues. And this is my graph for the equation y equals 1 over 4x minus 6. Example number 3. Graph the equation y equals negative x plus 5. So first, I need to identify my y-intercept, which is represented with b. So b equals 5. Now, I need to identify my slope, which is represented with m. However, I notice that I don't have a coefficient for my variable. So when I don't have a coefficient, that means there's an invisible 1 there. So my slope is negative 1. However, I always want my slope to be a fraction, so I'm going to write it over 1. So since my slope is negative, that means I'm going to go down 1, and then I always go to the right. However, in this case, it's only going to be to the right 1. So now I'm going to go ahead and plot my y-intercept, which is at 5. So 1, 2, 3, 4, 5. And then my slope is negative 1 over 1. So that means I'm going to go down 1 and then to the right 1. Now I'm going to go ahead and connect the dots. And then I want to include my arrows to show that this line continues. So this is the graph for the equation y equals negative x plus 5.